Hey, Calc AB, sorry I can't be with you today. I've got a doctor's appointment. But what I wanted to do was go over some of the implicit differentiation problems. These are on page 146. Hopefully you watched the video over the weekend. I'll run through the odd ones here fairly quickly. If you have questions, you can review the video at your leisure. Okay, so the task on each of these says find dy dx. Find dy dx, that's the rate of change of y with respect to x by implicit differentiation. And the first problem is a circle of radius 3. Okay, so here's question 1. X squared plus y squared is equal to 9. We differentiate with respect to x. So the derivative of x squared is 2x. The derivative of y squared is 2y times dy dx. Remember, this is something ugly here. And the derivative of 9 is 0. Okay, so there's the calculus step to solve for dy dx. You go ahead and move the 2x to the other side by subtraction, and then divide through by 2y. So dy dx is minus 2x divided by 2y, cleans up to minus x over y. Okay, number 3. Number 3, we have square root of x plus the square root of y is 16. X to the 1/2 plus y to the 1/2 equal to 16. And again, our task is to find dy dx. Okay, so we're going to differentiate x to the 1/2. That's the square root function, remember. That differentiates as 1 over 2 square roots of x. And this is the square root of y, which differentiates as 1 over 2 square roots of y times dy dx, right? Times dy dx, because y is something ugly. And so we have to take the chain rule into account. Okay, right side, the derivative of a constant is 0. So once again, we'll clean this up by getting the 1 over 2 square roots of x to the other side, minus 1 over 2 square roots of x. That's a subtraction problem. And then we'll multiply both sides by 2 square roots of y, 2 square roots of y, 2 square roots of y, and clean that up. So dy dx, obviously these go out, the 2's cancel, and we get minus the square root of y over the square root of x, which I suppose if you wanted to put it under one giant radical, you could do that. I'm not sure it's much easier or simpler that way. Okay. Number 5. Number 5, we've got some weird function, don't know the name of it. We've got x cubed minus xy, and then plus y squared is 7. And again, the task is to find the derivative implicitly. Okay, the derivative with respect to x of x cubed is simply 3x squared using the power rule. Now, this is going to be a little messy. This is a product. So let me put the minus sign down first, and then I'm going to take the derivative of that product. Let's see what we get. The derivative of a product is the first times the derivative of the second, which is dy dx, plus the second, which is y, times the derivative of the first. Well, the derivative of x with respect to x, I suppose we could write dx dx, but that's a little silly, so we'll simply write 1. Okay, so there's the product rule. Now we have the derivative of y squared, which is 2y to the first, right? That's using the power rule, and then the chain rule, dy dx. And the derivative of the constant is still 0. These first 3 all had constants on the right side. Now, let's see. That's the end of the calculus step. Let's see if we can do a little bit of algebra. First of all, I'll go ahead and distribute the minus sign. 3x squared minus x dy dx, and then minus y plus 2y dy dx is equal to 0. Okay, note that this term and this term have dy dx's in it, so I'll leave those alone, and I'll move the other terms to the right side of the equation. So I have minus x dy dx and plus 2y dy dx. And then using the idea of subtracting, we have minus 3x squared, moving that to the other side, and then moving that to the other side, plus y. Okay, so doing some more algebra, we're going to factor out the dy dx. All these terms have it. And that leaves us minus x plus 2y. And on the right side, minus x squared plus y. Whoops, minus 3x squared plus y. Minus 3x squared plus y. And lastly, we divide. So this is solving a linear equation, basically. dy dx is minus 3x squared y over minus x plus, minus x squared plus y divided by minus x plus 2y. Okay. I suppose if you multiply through by, -1 over -1, you could write this as 3x squared minus y and x minus 2y. Both of those are equivalent. I don't care which you have it. I'm not sure which way it is in the back of the book. Okay, number 7. X cubed y cubed. X cubed y cubed. Minus y is equal to x. Minus y is equal to x. Note, by the way, that for the first time, we've got something other than a constant on the right side. So just be careful when you differentiate x, you're going to get 1, not 0. Okay, so let's start off. We have a product here, so we're going to use our product rule. Derivative of a product is the first times the derivative of the second, 3y squared dy dx, plus the second, y cubed, times the derivative of the first, which is 3x squared. Okay, so that takes care of this product. And the derivative of minus y is minus dy dx. Again, we're differentiating with respect to x. And the derivative of x with respect to x is 1. Okay, so once again, sort of cleaning up here, this term has a dy dx in it. This term has a dy dx in it. So we're going to take that one and chuck it to the other side and then factor and divide. So oftentimes you can do this in your head, but let's go ahead and write out the steps here. We've got 3x cubed y squared, dy dx, that's that term, minus dy dx, that's the term over there. And on the right side, we have 1 minus 3x squared y cubed. Okay, we factor out the dy dx. So dy dx out of the first term leaves 3x cubed y squared. Out of the second term leaves a minus 1. 1 minus 3x squared y cubed. And lastly, we divide. Okay. So dividing through by that, we get dy dx is equal to 1 minus 3x squared y cubed divided by 3x cubed y squared minus 1. And I don't see any way to clean that up. No obvious simplifications there. There's your answer. Okay, next problem. Number 9. This just looks like a giant mess. We'll do 9. I'm not really enthralled with it, but what the heck. We've got x cubed minus 3x squared y, x cubed minus 3x squared y, plus 2xy squared, 2xy squared is equal to 12, another constant. Okay, so here's the differentiation. The derivative of x cubed is 3x squared, that's easy. Okay, I'm going to treat this again as a product. I'm going to treat it as the product of 3x squared times y. There is a negative sign that I'm going to bring down, and then the derivative of a product using the product rule. Okay, the derivative of a product is the first 3x squared times the derivative of the second dy dx plus the second times the derivative of the first, which is 6x. Okay? Now, for the third term here, we have another product. And I'm going to consider this as the product of 2x times y. Now, I could, sort of like I did with the second term, I could just bring the 2 down and differentiate that. But for this one, I'm going to do it a little bit different. You'll get the same answer either way. I'm going to treat this as the product of 2x times y squared. Okay? Oh, so the derivative of a product is the first, 2x, times the derivative of the second, 2y to the first dy dx, plus the second, which is y squared, times the derivative of the first, which is 2. Right? And the derivative of the constant is again 0. Okay, so we're going to have to clean up a little bit. By the way, that's the end of the calculus. The rest of this is just algebra. Go ahead and distribute this minus sign, clean up the left side a little bit. So I have 3x squared minus 3x squared dy dx minus 6xy plus, I'm trying to clean all that up. It looks like we have 4xy dy dx, and I will write this one as 2y squared instead of y squared 2 is equal to 0. This term has a dy dx in it. This term has a dy dx in it. So we'll chuck the other 3 terms to the other side. I'm going to try to do this in one step here. So let's see, dy dx. Now when I chuck the green arrows to the other side, I have a minus 3x squared, and then I have a plus 6xy, and then I have a minus 2y squared. After I do that, I would factor out the dy dx out of these other terms. Right? This one, you're going to factor out the dy dx, and then you're going to divide by what's left. So you take the dy dx out, and there would be a minus 3x squared, and then a plus 4xy. Any common factors? I don't see any common constants. There's no variables that are common. Bottom, there's an x, but there's not an x up top. So that's it. There's your answer. Okay, so let's do 11. That's a whole lot more interesting. Number 11. We finally get a trig function in here. So we have the sine of x plus 2 cosine of 2y is equal to 1. And we're differentiating implicitly. So the derivative of the sine of x is the cosine of x. That's easy. We have a 2 here. That's a multiplicative constant, so that just comes down. And now we have the cosine of 2y. Remember, the angle is not going to change. This angle is going to stay 2y throughout the entire differentiation. The derivative of a cosine is a negative sign. Right? Leave the angle alone. And now we have to take the derivative of the angle. Well, the derivative of 2y is 2 dy dx. 2 dy dx, and the derivative of the constant is 0. Okay, well, looking at this, there is only 2 terms here. If I clean it up a little bit before I do the algebra, just to make it look prettier. We have the cosine of x. This is minus 4 sine of 2 y. Sine of 2y dy dx is equal to 0. Right? So minus 2 times 2 is 4, sine of 2y, and good. Okay, so pretty straightforward. We would just write the answer down here. Let's see, you're going to chuck this term across, which makes it negative cosine of x, and then you're going to divide by all this garbage. So minus 4 sine of 2y. Okay, the only obvious simplification are the minus signs cancel. Okay, so cosine of x over 4 sine 2y. Okay, number 13. Number 13. Sine of x is equal to x times 1 plus tangent y, 1 plus tangent y. If I want, I could go ahead and distribute this and write it as the sine of x is x plus x tan y. We would have a product here that we'd have to deal with. Let's go ahead and do that. I'm not sure it's going to make a heck of a lot of difference either way. Okay, so now let's do the calculus. The derivative of the sine of x is the cosine of x. The derivative of x is 1, and the derivative of the product is the first, times the derivative of the second. The derivative of tangent is secant squared, leave the angle alone, followed by the derivative of the angle with respect to x, plus the second, tangent of y, times the derivative of the first, which is just 1. Okay, so let's see. This term has a dy dx in it. We'll chuck that across. We'll chuck that across. We have the cosine of x, take away 1, take away tangent of y is equal to, we have dy dx here, and then we would divide by the coefficient of dy dx, which is x secant squared y. I certainly don't see any simplifications there, so there's your answer. Just a nasty looking problem. Okay, 15. Let's see how long this is running. We're at 16 minutes. Okay, still chugging along. 15. Oh, y is the sine of xy. That's an interesting angle. It is a product. We're going to have to deal with the product rule when we do the chain rule. Okay, the derivative of y is dy dx. And the derivative of the sine of an angle is the cosine of an angle, x times y. Now we have to multiply this thing by the derivative of the inside, and that's a product. So the derivative of this xy is first times the derivative of the second plus the second times the derivative of the first, which is just 1. Okay. Now, to clean this up, we do have sort of some algebra we have to do here. This has got to be distributed here. So let's clean up the right side. We have dy dx. Over here on the right side, we have, well, I'll write the x first. X cosine of xy dy dx. That's the first term. And the second term, we have y times the cosine of xy. Okay. And again, we note we have dy dx over here and here. We're going to have to get those on the same side. I'm going to chuck this one across. And so that would leave me with the dy dx minus x cosine of xy dy dx. Just moving that term to the left. There's my equal sign. And on the right, I have y cosine of xy. Okay, these two terms on the left have a common factor of dy dx. Factor that out. So 1 minus x cosine of xy is y cosine of xy, and then divide. Okay, so dy dx is equal to y cosine of xy all over 1 minus x cosine of xy. Okay, you can check the back of the book and those first, 7 problems there. 1, 2, 3, 4, 5, 6, 7, 8. So we did 8 odds, and you can continue on with these if you like. However, what I'd like to do is I'd like to go back to the very first problem, which was this: a circle, x squared plus y squared is equal to 9. Now we know what that looks like. It's a circle, center at the origin, radius 3. And we were asked to find dy dx. If you recall, dy dx ended up being, let's see, well, let's do it again real quick. This was when we take the derivative, and we get 0, so we move the 2x, and we divide by the 2y, so minus x over y. That was our derivative. That gives us the slope of the tangent line, the rate of change, anywhere on this circle. What I'm going to do is I'm going to pick a point. Let's see, right here is 1, and there's a point on this circle where x is 1. Let's see, what would the corresponding y coordinate be? Well, that's just a simple algebra problem. If you put 1 right here for x, you get 1 squared plus y squared is 9, y squared is 8, y is plus or minus the square root of 8, which cleans up a little bit, plus or minus 2 squared root of 2. Now, obviously, if we're down here in the fourth quadrant, right, this point, then the x-coordinate is positive, and the y-coordinate would be the negative 2 squared root of 2. Okay, so there's a point on the circle, and what I'm interested in is the equation of this tangent line. Okay, so what is the equation of this line at that point on the circle? And we can do it a number of different ways. First of all, we need to find the slope of this tangent line, m tan. So let's see if we can do that. The slope of the tangent line is given by this. We've already done the calculus. So m tan evaluated at the point 1, negative 2 root 2 is going to be negative 1 over 2, negative 2 root 2, or 1 over 2 root 2, or if we multiply through by root 2 over root 2, we get, what, root 2 over 4, right? 2 times 2 is 4. Okay, so that's the slope of that line. Not a hard problem since we've already done the calculus. Root 2 over 4. Okay, I did want the equation of the line, though, so let's see. Y minus y1, m times x minus x1. That's our point slope form of a line from algebra. So we have the point. We can put that in. Y minus a negative 2 root 2. We have the slope. We calculated that, root 2 over 4, and then x minus 1. Okay, so cleaning that up a little bit. Y, this becomes a positive here. I'm going to chuck that across, and I get minus 2 root 2, and then plus root 2 over 4 times x minus 1. And that's the equation of the tangent line to the curve. Notice in this case, we did the calculus by differentiating implicitly. For many problems, you can differentiate explicitly, but to do that, we would have to go ahead and solve for y. So we still have the same geometry here. Let's solve for y. Let's see. We know y squared is 9 minus x squared. So y would be plus or minus the square root of 9 minus x squared. And on the bottom half of the circle here, right, the bottom half, we certainly have the negative root. So we're going to be dealing with this one here. You might recall back in Algebra 2, if you wanted to graph a circle, say we wanted to graph this circle, y is equal to, or x squared plus y squared is 9, y is equal to the radical of 9 minus x squared, 9 minus x squared, and that's the top half of the circle, and then the bottom half of the circle is just the opposite of that, right? And so here was the graph in the standard window. It sort of looked oval because the axes were not squared up. If we did zoom square, ironically enough, we ended up with a nice circle. Let's go ahead and draw the tangent line while we're at it. Remember the draw menu, third button, third row. We can draw the tangent, choice number 5, at x is equal to 1. Now, unfortunately, if you look in the upper left-hand corner, we're on the top half of the circle here. Well, that's not the one we want. We wanted the tangent line on the bottom half of the circle. So let's clear that drawing. And we're going to try it again. Second draw, number 5 is the tangent, but we want the other half of the circle. So I chose y2. Again, we're drawing it at x is equal to 1, and there we are. We might want to just sort of note that equation just to compare it with what we have over here. The calculator is saying y is equal to 0.353553415. That's a near rational number. X and then minus 3.18198, and that goes on as well. Okay, so that's the equation of the tangent line. This is what we have over here that we did analytically, no calculator. Let's just make sure it's the same thing. So if I distribute here, we get square root of 2 over 4x, and then we have, that's our slope, right? So that should correspond with that number. And then we have minus 2 root 2, and then distributing here would be minus square root of 2 over 4, and that would be the y-intercept, and that mess would correspond with that mess. So just to make sure that, you know, that we're not blowing smoke here, the square root of 2 divided by 4, sure enough, is this 0.35. Okay, so the slopes match. And the y-intercept, we had minus 2 root 2 minus root 2 divided by 4. And sure enough, that's the same as the y-intercept on the graphing. So let's see if we can find the slope by differentiating explicitly. Again, to do that, you have to solve for y, which we've done. We've got y is minus the square root of 9 minus x squared, and now dy dx. Okay, no implicit differentiation here. I'll bring down the negative 1. The derivative of the square root is 1 over 2 square roots, 9 minus x squared, and then we have to follow that by the derivative of the inside, and the derivative of 9 minus 2x squared is minus 2x. Okay, so just cleaning this up a little bit, the minuses cancel, the 2's cancel, right, 2's cancel, and so we get, what, x over the square root of 9 minus x squared. So that would be the derivative anywhere on the bottom half of this circle up here. Okay, but we wanted it when x was 1, so let's evaluate that when x is equal to 1, and we get 1 over the square root of 8, which is 1 over 2 root 2, which is root 2 over 4, same number we got before. In this case, we could find the slope of the tangent line explicitly or implicitly, or, believe it or not, without using calculus at all. You might remember some geometry. In a circle, the tangent to the circle is always drawn perpendicular to the radius, drawn to the point of contact. And then from algebra, you should remember that perpendicular lines have slopes that are negative reciprocals. So if we can find the slope of the radius here, then fit the negative reciprocal, and that would give us the slope of the tangent line. Okay, so here's our circle again. We have the origin, 0, 0, and we have this point on the circle, 1, minus 2 root 2, and we're just trying to find the slope of that line. So we're going to go down. This is the rise or the fall, if you want, minus 2 root 2, and we're going to go over 1. There's our line. So the slope of that line would be rise over run, minus 2 root 2 over 1. So the slope of the tangent line is going to be the negative reciprocal of that. So 1 over 2 root 2. Just take the reciprocal of this and take the opposite. Okay, so we actually get the slope of the tangent line for circles anyway. From geometry, do not need calculus. Okay, let me go ahead and stop this video here. I'll continue working on these tomorrow. I do want to start related rates. I'll probably do a short video this afternoon that I'd like you to watch tonight, so that when we come to school on Wednesday, we can talk about related rates intelligently. Thank you very much. And I'll stop at 30 minutes.